Hello everybody, my name is Sarah Abotsi-Masters. I'm one of the NIEX for Ghana. It's my great pleasure and honour to be here today, and I'm going to be talking about ways of observing solar eclipses. So let me just start my slides. So as well as being one of the NIEX for Ghana, I'm also the General Secretary of AFAS, that's the African Astronomical Society. I'm the Voluntary Events Coordinator at the Ghana Planetarium. I've been involved there since 2009. And I'm also part of the PRAGSAC project in Ghana, which is basically to do with setting up astronomy clubs in schools to promote astronomy and radio astronomy, and also an instructor with PASIA. That's the Pan-African School of Emerging Astronomers. So let's get on to solar eclipses then, because they're amazing, they're awesome. They're probably one of the most spectacular and awe-inspiring celestial phenomena you can possibly see. There are about at least 2 a year, a maximum of 5 per year. But even so, as you can see in the middle picture taken from the ISS, because the shadow of the moon on the Earth is small, it means that for any given location on Earth, it'll only experience a total solar eclipse on average once every 400 years or so. Now that is very much an average. There's a lot of variation in that number, but basically we're saying that it's like a once in a lifetime opportunity to see an eclipse. So if one is happening, you really want to take the opportunity to see it and to encourage everybody else to see it. I was very fortunate that I was able to see a total solar eclipse here in Ghana in 2006. And so here's a photo of my mum enjoying the eclipse from the comfort of our front yard. We were very lucky. We had perfect conditions. We didn't have to travel anywhere, and we really were very fortunate. And then after that, there were 3 partial eclipses in 2013 and 2016 and 2017 that I also got to witness. And by that time I was involved in the planetarium and we could organize events for that. Now, it's a fantastic opportunity to engage with the public when an eclipse is coming. And I think this is particularly important if you're in an area where there's maybe, if you like, low scientific literacy. Here in Ghana, there's very little science journalism. You rarely hear or see any articles about science or about astronomy. But when the eclipse came, then it was headline news across the mass media. So that was great because it was really reaching so many more people. Now here's the geometry of a solar eclipse, which I'm sure you're all familiar with, but this gives you so many opportunities for education and communication about astronomy, because people will ask, what is an eclipse? How is it formed? And that means you can talk about the movement of our Earth, Moon and Sun system, the relative sizes of the moon and the sun, the relative distances of the moon and the sun, the phases of the moon, because the eclipse happens at new moon. And then if there's an annular eclipse, you can also talk about the elliptical shape of the moon's orbit. And you may even get asked the question about why isn't there a solar eclipse every month? And then you can also discuss about the tilt of the moon's orbit. So you can get people excited about the solar eclipse, you can educate them about how it's formed, but then how do they observe it? So usually everybody talks about the eclipse glasses, which are, if you like, the gold standard, and they are fantastic. But in a lot of places, they're not accessible, you can't get them, or they're not affordable. At the planetarium, we were lucky enough to get donations of glasses from organizations like Astronomers Without Borders and others, but there are never enough. There's never enough glasses for the people who want them, and you can never reach everybody with the glasses. So what else can you do? No eclipse glasses, no problem. Instead, you could use something called the pinhole method, and I'll talk about 2 variations, the basic method and the reflected pinhole method. And the great thing is, for this, you don't need to build or make or buy anything. You can just use what's around you. You can use any household utensils that have small holes, something like the colander at the bottom there, or the grater, or a kind of straining spoon any of those will work. And we actually use these to great effect at one of our events. You can see in the top left corner the image from the colander, which worked really well. So basically the light comes through the holes and you get multiple images of the partially eclipsed sun. And then over on the right, you can see some of the young visitors trying out the spoon, which also worked very well. So how does this work? Well, it's basically because an illuminated object reflects light in all directions. But if you have a small enough hole, normally just a few millimeters, then it means that only the light that's coming directly from the different parts of that object can pass through. And so then you get an inverted image, a clear inverted image on the other side. And if you don't even have any utensils, there's other things you can use. Here are just some examples from online. You can just use your interlocked fingers to produce little gaps, or you can use the gaps between leaves on a tree. You can see on the right-hand side there. Or you can just put a hole in a piece of paper. And in fact, then people can get very creative with the two examples at the bottom there. If you create a pattern of holes on a piece of paper or card, then you'll get this pattern of the eclipsed sun when you view it. So on to the reflected pinhole method. Now this takes a little bit more setting up, but it still can produce good results. And the advantage is you can usually get a bigger image so that more people can enjoy it. So as the diagram shows, you take a mirror, you need to cover it in paper or tape so that you just have a small gap, like at the small pinhole left. And then you angle the mirror so that it reflects the sunlight onto a screen or a wall or a poster, something like that, preferably into a darkened room. So you're reflecting from the outside, maybe in through a window of your house or the doorway of your house, something like that. Now, the diagram shows the mirror sort of held on a stand, but if you don't have that, you can just put it on a table or chair, but you do have to make sure that it's taped or stuck down with glue tack, something like that, to keep it steady. And here are some photos of how we use that again at the planetarium. So again, that worked very nicely. We reflected the light in through the back door of the planetarium. What you need to do is experiment a bit with the distance between the mirror and the screen, so that you can either get a brighter image or a sharper image or a bigger image. In our case, the mirror was probably about 10 or 20 meters away, and the image that we got was probably around 20 centimeters. So that was pretty good. So there we are. That's two variations of the pinhole method for viewing eclipses, and it provides a very safe, simple and accessible and affordable means to view an eclipse. And again, the safety is the most important thing, because as we know, there can be a lot of misinformation or fake news out about how you can and can't see an eclipse. So if you can give people a very simple and safe way to view it, then that's the best idea. So it allows you to engage with the public, get them excited about the eclipse, inspire them and educate them about what an eclipse is and how it's showing the movements of our Earth, Moon and Sun system, so that in the end, everyone everywhere can enjoy this unique spectacle. So thank you very much. That's all from me. Bye.